All right, guys, welcome back to Pre-Calculus Math 1800 at Wayne State University. My name is Resh Mahaber. We're almost close to Super Bowl kickoff time, and I wanted to go ahead and check in with you guys to talk about a gigantic topic. This will be a slightly longer video, about 20-25 minutes. And you need to stick in for the long haul because this covers probably the hardest topic in all of mathematics and probably all of the world. We're all about human beings and why are functions so important, because that's what we've been talking about for the last couple of videos is functions. They're so important because do we actually know what's going to happen in the future? Let me give you an idea. This would happen now. This would happen a couple days ago. Well, we could track all these points, right? Right? This is tomorrow, or let's say 2 days from now. Okay? What we try to do as human beings is say, hey, there's some pattern, and this is what I can project might happen. And within a certain amount of correctness, we call this a confidence interval. How confident are we? But a certain amount of correctness. And this is what we're all about, is about creating. Now notice, this function is created by putting a number of variables together to make one giant function. This is huge. And this right here is the whole point of creating what's called a modeling function. Modeling functions allow you to look at one complex issue in terms of like many other issues. Okay, so I'm going to give you a real life idea if I can get rid of all this nonsense I just drew. Because it is extremely important. It's probably the most important topic you'll do. In Calc 1, you'll create a modeling function and then maximize or optimize them. And in Calc 2, you'll be constantly modeling things in terms of other things. I know things is such a vague topic to do solids of revolutions or just integrals in general when we start talking about work functions and volume. In Calc 3, it seems like that's all you're ever doing when you're trying to figure out what a function really is. So this is a huge topic. If you're not good with it, then you need to watch this video multiple times and maybe even save it so you can bring it back when you take calculus or calculus for sure. I don't know a better way of doing it. I was just thinking to see if there was some other way we can handle it, but modeling function is huge. All right, so let me give you a real life example. How many people have bought pants? I know this seems weird. Let me blow up my screen because you guys are probably going to look at me like I am weird. What do you mean by buy pants, Rush? Well, what I mean is that buying pants, the decisions we make might be, let me write this a little smaller. Pants, this might be a yes or no for people. Okay, so I'm not going to get you to figure out an output, but what are some things that you figure out in order to do this? Now, we call this dimensions in Mathland, but if you're a one-dimensional buyer, meaning like me, I'm a one-dimensional buyer. I go in, I say, give me the size 34 by 32, and they give me that, and I walk out. I don't try anything on. I'm not trying to have a conversation with you. I really just want to get my number and go. And this is how I do things. I'm a very simple guy. But for some people, their functions are way more complex. Their pants is not just, it doesn't just come down to size. It comes down to color. It comes down to, and I mean color can be, I had a fashion student the other day who was telling me that, you know, vertical threads being one way, horizontal threads, like white on blue, give you a different kind of jean, denim color than blue on white. Go figure, right? And this is the stitching we're talking about. So size, color, for me, maybe one other thing that I do look at is price, right? Length, cut, right? Boot cut. I forget what it's called. Yeah, cut, right? Boot cut, relaxed fit, straight fit, right? Or maybe that's not cut, that's fit, right? Well, if you just look at these, that means if you're not me, I'm a one-dimensional buyer. But all these, the person who buys pants like this, not to mention your I think this is complex, but you have 1, 2, 3, 4, 5 variables that you use to buy pants. That's a lot in my eyes, just to say yes or no. Well, once again, what if I said that it might be easier to do this if the pants itself, what if size was a function of time? Meaning that It might be some guy where t can be the guy, meaning that it might be t squared plus 1. Maybe what the size you wear varies with the months, right? I know I put on a little bit of poundage during the wintertime. Same thing with colors. We don't wear white after Labor Day. Maybe that's another function in terms of time. Square root of t, for example. Say that's a function. Price. Well, I don't know how jeans are, but I tend to buy them on sale. So maybe the price is in terms of time. Maybe you look for the change in the seasons like I do. Maybe that's t to the 1/3, right? And then the length, right? You would want a taller size pants if you're wearing boots. And if you're not wearing boots, you'd want a shorter pants, otherwise it would drag on the ground kind of a thing. So maybe that is also a function of time. So the length is also a function of time. Maybe that is t over 1 over t to the 3rd plus 1. And then maybe the fit, maybe that's the same all year round. Doesn't matter what. You're just the kind of guy or girl that likes relaxed fitting jeans. So that's the function that is the number 4. Done. Right? That's the fit you always wear. So does it really make sense to go walk into a store and tell the salesperson that I need a size 32 that is black with white threads, less than $25, a length that is about 42 to 43 for this season, and then that fits me as a size 4? When you could just walk in and tell your sales guy, hey, notice every one of these functions is in terms of time. Right? So what if we didn't sell pants according to all this other nonsense? We looked at just time, since it is the variable that everything else depends on. So instead of looking at the pants function in terms of 5 other elements, I would only be looking at time. And then you walk in and say, hey, sales guy, give me t equals 9. My team at Stanford is September, but give me the t equals 9 pants. He just gives you those and you walk out the house. I'll walk out the store. Done, right? It takes it back, and that's like what modeling function does. When you have to monitor only one variable, and this would be the end of the problem. It's way easier to make decisions. Companies do this all the time to make sure they're operating at best efficiency. So that's all we're gonna be doing is focusing on turning a multi-dimensional problem into a one-dimensional problem, just in terms of time. That's it. Okay. So without further ado, let's get started. Like I said, this is going to be a longer video, guys, so try to stick with it. Let's zoom out a little bit. So you'll notice I already have some word problems already previously typed, just to make things a little easier. But to be honest with you, I don't think anything makes these easier, because you have to read and comprehend and kind of get an idea of what's going on. We've dealt with word problems in the past, so I'm assuming that you have an idea of just how we read problems. Remember, read them slowly, and if you struggle with word problems, go back and look at my video that I entitled Word Problems. I think it's section 1.8, but it allows you to actually get an idea of how you should be reading and approaching these. Okay, it says a rectangle. Guys, the minute you read something, you should be drawing it. So let's see if I have a shape. Oh, I do. I have shapes. A rectangle. Boom. Okay, and what am I doing here? I'm outlining my given information, which is what you should always do. Has an area of 16 meters squared, or square meters. So the area, which is the stuff on the inside. Now don't get ahead of yourself. Okay, the square meters, it lets me know this is meters by meters. Okay, it's not an actual thing you put in there, but this lets me know that the stuff on the inside is going to be equal to 16 when we multiply it together. Said and done. How do I know that? Because I know what the area of a rectangle is. Just give me my given stuff, okay? So express. Here's the goal. Here's the goal. We need to express perimeter. Anybody know what perimeter is? Well, perimeter, if I remember correctly, is just the sum of all sides, which means we're just adding all the sides together. So if you are a formula memorizer, I recommend you don't memorize formulas. That's why I went into mathematics, is so that I don't, so that you don't memorize anything, okay? So I just know that you have two sides that are the same and the other two sides that are the same. We normally call this side length and this side width. So I have two lengths and two widths. Therefore, I'm going to have two length sides and two width sides. Now this is what I'm going to recommend you do. Don't put L and W in here, because that means that you've introduced variables, and be honest with you, we really don't know what the variables stand for. So somewhere along these lines, we're going to have to take our time and make sure that we understand what the variables stand for. So try not to introduce variables unless you absolutely have to, and because you never know. We haven't finished reading the problem. One of these variables might be labeled something, okay? So express the perimeter of the rectangle. Okay, that's what this is. That's the goal. As a function of length x of one of its sides. So here's what I want you to get. Perimeter, let's call this L and W. I know I just told you don't do this, but I'm going to do it. And because it'll correspond to L and W. Okay? This is a two-dimensional thing. You need two values in order to get the output, right? Of course, they never write it like this. I just wrote it like this so you see that I need two inputs to get the output of perimeter. Here's my point. This is bad news. We don't want this. We want the perimeter to be expressed in terms of x, okay? And x as a function of the length x. So length isn't even L, it's x. They labeled it appropriately, right, of one of its sides. So that means that this L really is a 2x. Now life is good because L to x is good. That's a good transformation. L goes into x. L turns into an x based on how we label things, but this width is still the width, which is okay, but there's a problem. We need it to be a function. We need it to be a function of just x's. So this width, we need to figure out some way to write width in terms of x, plug it in here, and then we are done. That's it, okay? So here we go. Well, what piece of information did we not use? So here's our given, here's our goal. We just need to figure out some way to write width in terms of x's, plug it in, and we've modeled the function just in terms of x's. Well, we haven't used this bit of information. Now, what is area of a rectangle? Length times width equals 16. Oh, look. That means width is 16 over x. Hence, if I were to plug this big, beautiful blob in, we get 16 over x times 2 plus 2x, just writing it down. And my function's done. Obviously, you should simplify this down. This is it. Here's my modeling function. They're not very hard problems to do. The point is you got to know what the goal is, or your given information is. You got to know what your goal is, know which variables and you're trying to transform into whatever variable we're trying to model it in terms of. And then once you plug it in there, we're done. It's very, very simple. Okay? Very easy. Let's talk about one that's a little bit more realistic. Okay, here we go. A farmer wants to fence in a rectangular plot of land. Here's my rectangular plot of land that I've posted here as of earlier. Let x in feet, comma, be the length of the plot of land. So I'm going to call this thing x. Inside the fenced region, which is all of these little spots, he wants to place 3 dividers, which is what I placed in the middle. And I placed them here randomly, but obviously they could be somewhere else, right? So if you might have a pig pen in here. He's a farmer, obviously. He might have green beans going across the fence. He might have some tomatoes. He might have some watermelons. Okay, it depends on what he's growing, right? So you might have different spacing. Here he only has 100 feet of running fence. That means to construct all of this crap, he has everything. He has to make 100 feet of fence, okay? If the area represents, if A represents the area of the rectangular plot, express A as a function of x. Alrighty, guys. So once again, let's figure out what the given is. I'm going to go through and read it again, and we'll figure out what the goal is. The given. The farmer wants to fence this guy in. X is the length. We did that. So my picture is part of my given. He wants to place 3 dividers. He has 100 feet of fence. So I need you, it's okay, so that's what they gave us, 100 feet of fence. I don't need you guys to do anything yet. If A represents the area of the rectangular plot, express the area. So our job is to express area in terms of x. Well, what is area of a rectangle in general? Area is length times width, and I will always write the words out just because I don't know what they're called. Like for example, the length here is x, so this will be x. But what's the width? I don't know. So this is where you have to introduce a dummy variable. Introducing dummy variables make calculations easier. Notice how I didn't tell you what anything has to be, or they didn't tell you what the width has to be. But to do this, it'll make you, like once we've snatched out all the given and goal part of the information, it'll be nice if we call this w. Why? Because then I can say that this thing is going to be w, and I know this can't be a w, it has to be an x. My job is to find w in terms of x. So what's the only piece of information we didn't use? This idea behind the fencing being 100 feet. So this is where you got to use some common sense. How much? Where's all the fence at on my picture here? Well, I have two x sides, this side and this side. So I have two x's. But I not only have this side, which is w, and this side is w. These are all the same dividers. So that's 5w's equals 100. It looks pretty easy to me. Solve for w. We get 100 minus 2x all over 5. That's w. Now guess what do we do here, guys? If you guess plug it in for w, you are absolutely correct. So x is 100 minus 2x over 5. We are done. So modeling functions, if you take a second to just look at your screen right now, there's not a lot of work. Everything that we're doing is being virtually done in our head. These are quick problems, but you have to read and understand and comprehend, and you have to figure out what do we need to express in terms of another variable. And if you could do that, then we're ready to rock and roll. That's really where the game plan is going to have to become at. Okay, so here's a real good one. Okay, this is one I recommend you pause and do. Okay, I always find this one's cool because it actually has some info that you normally would not see. This is a very, very weird one. And of course, then I will type in one last one that you guys can do and turn it in class. Okay, it says the surface area of a rectangular prism is 300. So here we go. Given goal. Okay, it says the surface area. Do we know what surface area is? If you don't, it's okay, not to fret. We will Google it in a second. Okay, is square inches. If the base of the prism is a square, okay, so now I'm bugged because they give me rectangular prism. I gotta know what the shape is, right? Because they just referred to it again and said the base is a square. So what does this mean? Okay, a rectangular prism is a box, guys. It's a rectangle. So it looks like this. I know you guys are used to triangular prisms, the one you saw in grade school where they would like put light through it and a rainbow pops out, but it's a rectangular one. Okay. Now the next sentence, it says the base is a square. So my picture is totally trash now because the base is a square. Now if you can't see 3D, I apologize, but you're going to have to put in some work to actually learn how to draw these shapes. Or hope somebody gives you to them on an exam, which I don't think is good. And since I know it's a square, I can tell you, this is still the given, that this is x and this is x. Both these sides have got to be the same. Okay, so I got up right here. This is the given information. Goal: express the volume. Anybody know what volume is? Oh boy. In terms of one of its sides of the base of the prism. So in terms of one of the sides, it basically means express the volume in terms of what I have labeled here as x. So here we go. What is volume? Well, in 3 dimensions, it's kind of like what you would think it would be. It's length times width times height. Okay? And it's pretty straightforward, right? Well, let's see here. Let's take a quarantine of what we got. Length is what, guys? Well, that's just x, right? I'll call this length. Width is just x. I'll call this width. And then we have height. So I'm going to call that a dummy variable. Call it h. So here's my goal. If I'm going to model this in terms of just x's, this cannot be here because I want just x's in my function. So that means I need to get rid of these h's and do something else with it. So what's the only other piece of information? Because if you notice in all these, they had to give us a piece of information to actually figure out what how to make that h in terms of x's. They give us this blob, which is surface area. So what is surface area? And I want you to use common sense. Surface area is exactly what you think it is. Area of the surfaces. It's like 3-dimensional perimeter. So if you think about this shape, how many faces do you have? Well, I have a top face. Oop, that's the wrong shape. I'm sure that's the wrong shape. Let me get rid of that. I have this thing. I have another one of those things. Let's see if I can make another one of those. And I have another one of those things. Looks about the same size. That's supposed to represent my bottom and my top. Okay, and then I have the side pieces, the side panels. Well, how many of those do I have? Well, I have 1, 2, whoops, 2. Okay, look, I'm just going to draw them. 2, 3, and 4. Okay. Now, there's some things you're going to have to like really visualize here, so stick with me. This side panel has, remember, it's surface area, which means area of the surface. So this blue space, let's call that this. Well, what's this? Well, this is x and this is h. That means this area in here is just xh. Okay, well, what do you think this one is? Well, if this is the same thing and this is h, the front side has to be xh and xh and xh. The bases are squares, so that's x, and this is x squared as well, right? Bases are squares, right? X times x is x squared. Surface area is just sum of surface area, or area, sum of areas of surface, right? So total surface space, surface. So what do we end up getting? Well, here we go, guys. The pieces of the puzzle. Notice this one's a common sense graph. 2x squares. I have 4 xh's, and then finally I have 320. Can you solve and plug something in here? I don't like h. Remember, that was the goal. Well, h is going to be 320 minus 2x squared over 4x. Let's use some common sense here. I should probably simplify this. You see 2 goes in everything? So this is 160 minus x squared all over 2x. That is what h equals. What are we going to do with that? That's right, you guessed it. Shove it in. We have successfully modeled in terms of one variable. But don't forget, you should always simplify when you're given the opportunity. Here's the opportunity. That'll go with this, which gives us x times 160 minus x squared over 2. Here's our volume, modeled in terms of just x, one on the sides of the squares. So this is really not all that bad. It just, if you look at the work, it's really not all that work. It just takes a lot of reading comprehension, which is terrible for a lot of people. Okay, so here's a problem for you to do that I will definitely take from you tomorrow morning. Okay, or when next time I see you, if you want to shoot me an email. A landowner, okay, wants to fence in a rectangular piece of waterfront property. Now, obviously, if you are a good owner of your waterfront property, you would always like to make sure you put fences on 3 sides, not every side, because you won't be able to see the water. So she needs fencing on only 3 sides. Okay? And has a total of 18 yards. Oops, total, and has a total of 18 yards of fencing. Fence. There you go. Here's your job. Write a function representing the area A of the fenced in property as a function of the width, but I don't want you to call it W, I want you to call it X. Okay, and look, I'll even give you a picture. Okay, so here's the picture. Here's your property, boom, 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 it's rectangular, water is here, here's your width, and here's the land. Okay, so do that, and I will collect this from you mañana. Once again, if you want to go somewhere and do some things you've never done, guys, you got to step out the comfort zone and understand that you've only been taught the tip of the iceberg. And here's the funny part about life. I've learned that the more I know, it doesn't let me know more. It just exposes how much more I still have to learn because I'm no longer ignorant. So keep learning as much as you can. Stay hungry and always think of the next step. Suresh Mahaber signing off.